Do you know how to graph exponential functions? What about logarithmic functions? Hi, welcome back. In this video, we will learn about exponential and logarithmic functions and how their graphs look like. At the end of the video, you'll be given two problems to try on your own. Now, what are we waiting for? Let's get to work. Let's start off with exponential functions. The general form is a times b to power x, where a is the initial value and it's not equal to 0. B is called the base of the exponential function, and we need to make sure that it's greater than 0 or it's positive and not equal to 1. So these are some conditions that we have to keep in mind. Now let's look at the graphs, the possible graphs of an exponential function. This graph is for the case of b greater than 1, like 2. For example, f of x equals 2 to power x or 3 to power x. Okay, the graph looks like an increasing function, and the y-intercept is at 0 and 1, and it doesn't have any x-intercept because there is a horizontal asymptote at y equals 0. The other graph on the right, it's for the case of b between 0 and 1. For example, b equals 1 over 2. Like f of x equals 1 over 2 to power x. And as you can see, now the graph is decreasing. The y-intercept is still at 0 and 1. There is no x-intercept, and the horizontal asymptote is at y equals 0. Let's summarize the features of these two functions. In this table, I'm going to list domain, range, and other features. And this way, we can compare the two graphs easily. In terms of domain, you can see that the graph of this function covers everything on x-axis from far left to far right. So I can use negative infinity, comma, positive infinity for the domain of each. For the range, however, you can see both functions are above x-axis, where x-axis is basically the horizontal asymptote, and it's not going to touch the horizontal asymptote. Therefore, I can write the range as 0, comma, positive infinity, and that works for both of them. And y-intercept, as I mentioned, is going to be at y equals 1, or 0, comma, 1. Horizontal asymptote is y equals 0 for both. What about increasing / decreasing? Which one is increasing? Obviously, the left one is increasing. So the base is greater than 1, like b greater than 1, then the function is going to be increasing. If b is between 0 and 1, then the function is decreasing. And concavity, both of them concave up, so that is the same for both. Now let's try some examples. In the first example, we got negative 3 to power x. Here's the plan. I know how to graph 3 to power x. The base is greater than 1, and I know it's going to be an increasing function. So I will start with that and then multiply by negative 1. All right, so I start with xy axis, and I graph an increasing exponential function. All right, this is y-intercept of 0, comma 1. Now I want to graph negative 3 to power x. I just need to reflect it over x-axis. It's like multiplying this by negative 1, so it's a reflection over x-axis. And now 0, comma 1 is going to change to 0 and negative 1. So the graph in the top is actually 3 to power x, and the one below x-axis is negative 3 to power x. Next example is negative 1/3 to power x. In this case, 1/3 to power x is a decreasing function. So the graph of it looks like this. Y-intercept is still at 0, comma 1. Now we reflect it over x-axis since it's multiplied by negative 1. And that's going to give me this graph. So the one above x-axis is 1/3 to power x, and the one below is negative 1/3 to power x. As you can see, the first graph on the top is decreasing. Now it's actually increasing. For the case of negative 1/3 to power x, is an increasing function. The last example, h of x equals 1/3 to the exponent of x plus 2. I have an idea. We know how to graph 1/3 to power x. So let's assume f of x is 1/3 to power x. We know how the graph looks like. It's like an decreasing function, which we tried it in the second example. Now h of x is like f of x, where x is replaced by x plus 2, which means h of x is f of x plus 2. When we replace x with x plus 2, it means to shift the graph of f of x 2 units to the left. So I start with the graph of f of x, which is a decreasing function with y-intercept at 0, 1. Now it's shifted 2 units to the left, so we need to shift the entire graph 2 units to the left. Okay, that means this point of 0 and 1 is now going to be at -2 and 1. So this is -2 and 1, and then continue drawing the rest of the graph, which looks like this. Now, as you can see, the y-intercept is not at 0 and 1 anymore. So if I call the first function, let's write it down. This is f of x equals 1/3 to power x. The next one is 1/3 to power x plus 2, where we need to find y-intercept. To find y-intercept, you can just replace x with 0. That's going to give me 1/3 to 0 plus 2, or 1/3 squared, which is equal to 1/9. So if I show the y-intercept with red color, that's going to be at 0 and 1/9. Okay, now let's learn about logarithmic functions. The general form is y equals log base b of x, where x and b are positive and b not equal to 1. We can convert this to b to power y equals x. So we can use these two interchangeably. Basically, a logarithmic function is an inverse of an exponential function. If the graph of an exponential function b to power x looks like this, where b is greater than 1, so this is the graph of b to power x with b greater than 1, the inverse of it can be drawn by reflecting this over the graph of y equals x. So this dashed line represents y equals x. If I reflect the blue line, b to power x, over the dashed line, I'm going to get this graph. Where on the blue line, the y-intercept is at 0, 1. Now on the new graph, we don't have a y-intercept anymore. Instead of that, we have an x-intercept of 1 and 0. This is going to be the graph of log b of x, where b is greater than 1. So we did that for b greater than 1. Now let's try it for b between 0 and 1. If b between 0 and 1, then the exponential function is a decreasing function. If I want to graph it, reflect the graph over y equals x to find the logarithmic graph, this is y equals x, the reflection of this line is going to look like this, where ideally this should go through 1 and 0. So the x-intercept is 1 and 0. And this red line is the graph of log b of x, where b is between 0 and 1. Okay, in summary, we can have these two graphs for a logarithmic function, log b of x. When b is greater than 1, we're going to have an increasing function. If b is between 0 and 1, we will have a decreasing function. And in both cases, the x-intercept is 1 and 0. Let's summarize the features of these two graphs. As you can see, domain is covering everything greater than x equals 0. Since x equals 0 is basically the vertical asymptote. So domain is 0 to positive infinity for each of these two graphs. The range, however, the range covers the entire y-axis. So negative infinity to positive infinity. And you can think about it in terms of inverse functions. When we inverse the graph of b to power x over y equals x, we actually swapped x with y. So in the exponential function, domain was negative infinity to infinity. Now in the logarithmic function, range is negative infinity to infinity. For y-intercept, we don't have it anymore. Instead, we have x-intercept at 1, 0. Vertical asymptote, that's at x equals 0. And lastly, when b is greater than 1, then the function is increasing. And if b is between 0 and 1, then it's going to be a decreasing function. Now it's your turn. In the first question, we want to find the horizontal asymptote of f of x, where it equals 2 to power x minus 1 plus 3. And in the second question, we want to know if this function is increasing or decreasing, where the function is negative log base 0.3 of x plus 2. Find your answers and leave it in the comments. That's it for exponential and logarithmic functions. I hope you enjoyed this video. If you did, please give us a thumbs up and subscribe for more math problems. And don't forget to leave your answers to the challenge question in the comments. Until the next video, keep solving those math problems.